Alright, so this is the Physical Science Section 11.2 lesson video. And don't forget, if you want to get all my videos in one place easily, then just subscribe to my channel and you'll have them all there together. Alright, so in Section 1, we discussed the difference in distance and displacement. So in Section 2, we're going to discuss the difference in speed and velocity. So speed is the ratio of the distance an object moves to the amount of time the object moves. So it's distance over time. The SI unit for speed is meters per second, or m/s. Now, of course, in America, we use things like miles and feet and things like that for our distances, but in science, we don't focus on those. We focus off of the base unit of meters. Okay, so like whereas in America, our speed limit signs are in miles per hour, when you go to other countries, they use things like kilometers per hour, so you'll see a lot higher numbers on their speed limit signs, even though the speeds are about the same when you convert. So average speed is the total distance traveled, which would be your d, divided by the time, or your t, it takes to travel that distance. So average speed is total distance over total time. So most of the time what you'll see me write in class is speed equals distance over time. I just leave off the totals and I just know mentally that I need to add them up if I'm given multiple ones. So let's look at a sample problem. It says, while traveling on vacation, you measure the times and distances traveled. You travel 35 kilometers in 0.4 hours, followed by 53 kilometers in 0.6 hours. What is your average speed? Okay, so we know speed is distance over time, so let's add up our distances. So we traveled 35 kilometers, and we traveled 53 kilometers. So that's a total of 88 kilometers that we traveled. All right, and then we got to add up our times. So it says we did 0.4 hours of traveling and 0.6 hours of traveling, which of course adds up to be 1 hour total. So this math is really easy. So once I have my total distance and time, I can plug into my formula. So my distance was 88 kilometers. My time was 1 hour. And so of course 88 divided by 1 is 88. Now kilometers an hour will not cancel, so we keep both units. So it's kilometers per hour, just like that. All right? Some of you may have used this formula before, probably in middle school. All right, so let's look at a couple more to make sure you can do them on your own. So what you want to do now is just pause the video, try these on your own, and then you can start the video again and check your answer. So we'll go ahead and start together. So it says a person jogs 4 kilometers in 31 minutes, then 2 kilometers in 22 minutes, and finally 1 kilometer in 16 minutes. What is the jogger's average speed? Okay, so again, we know speed is distance over time, so let's add up our distances. So we have 4 kilometers, we have 2 kilometers, and we have 1 kilometer, which is going to give us a total of 7 kilometers that this person jogged. So then we add up our time. So we have 32 minutes, we have 22 minutes, and we have 16 minutes. And so when we add up our minutes, you get about 70 minutes. So now we know our total distance was 7 kilometers, we know our total time was 70 minutes. So I can plug into my formula. So my 7 kilometers divided by 70 minutes, and that gives me 0.1, and then remember a kilometer and a minute are not the same, so they will not cancel. Kilometers per minute, just like that. All right, so hopefully you got that one right. All right, so let's look at our second one. So again, if you haven't already tried one, pause, try it, and then check your answer. So it says a train travels 190 kilometers in 3 hours and then 120 kilometers in 2 hours. What is the average speed? So again, we know speed is distance over time. So let's add up our distances first. So we have 190 kilometers and we have 120 kilometers. And so that's going to give us a total of 310 kilometers. And then we add up our times. So clearly you can probably do this part in your mind, but I'm still going to write it out. So we have 3 hours and 2 hours, which clearly is a total of 5 hours. And so once you get your totals, you can just plug in. So my total distance was 310 kilometers. my total time was 5 hours. And so once I divide, I got 62. And then again, a kilometer and an hour is not going to cancel. So kilometers per hour. All right, so hopefully you tried those on your own and hopefully you got them right. Okay, so let's move on. All right. So what we just calculated was average speed. We have multiple distances over multiple times. You can also calculate instantaneous speed. So instantaneous speed is the rate at which an object is moving at a given moment in time. Oh, there's a typo. Should have said is. I make the PowerPoint, so of course there's typos in them. All right, for example, you can describe the instantaneous speed of a car by looking at the speedometer. So like when you're in a car driving, if you speed up, the speedometer automatically goes to a higher number. If you slow down, the speedometer automatically slows down to a lower number for you. And so it's showing at that exact moment in time, how fast are you going? That's instantaneous speed. Whereas average speed, I could calculate on average how long, how fast was I driving to work. But I mean, when I'm driving, I'm going to have to slow down sometimes. I may get a red light. I may have to do get a stop sign. So I'm not traveling the same speed the entire way to work, but I can calculate the average speed. Whereas instantaneous speed, my speedometer is going to tell me at that moment how fast am I going. So we do a lot of graphing in here, so you got to make sure you know how to read graphs. The EOCs like to have graphs on them. So the slope of a line on a distance time graph is the speed. Okay, so if you look at this line here, we have a slope. This line here, the slope is 0, which means at this point we are not moving because we went 6 kilometers and we stayed at 6 kilometers for a while. So maybe that means they were driving and then they stopped, maybe got gas or something, and then started driving again. So how do we do slope? Well, slope is rise over run, change in x over change in y if you needed to actually calculate it. But slope is how we get speed on a distance time graph. So the steeper the slope of the line, the faster the speed. So like here, we're only going 5 meters per second. Here it's a little bit steeper, we're going 10 meters per second. Here it's even steeper, we're going 20 meters per second. Then there's also a difference not only in the steepness of the slope, but what the line looks like. Is it a straight line or is it a curved line? Straight lines represent constant speed. So what that means is on this whole line, because it's a straight line, they're going 10 meters per second. Whereas if you have a curved line like this, like here, they're probably going kind of slow because we almost have a 0 slope right there. Then we get a little bit of a slope, so we're kind of getting going. Then we're starting to get a bigger slope, so we're speeding up, speeding up, speeding up, speeding up, like that. Okay, so a straight line represents a constant speed. A curved line on a distance time graph represents a change in speed. In this case, we're speeding up because our slope is getting steeper and steeper as we go. So let's talk about velocity now. So speed was our distance over time. Velocity is a description of both speed and direction. Velocity is a vector. Okay, so if you watch the section 11.1 lesson video, we talked about vectors. All right, they have a magnitude, which is a number, and a direction. So in other words, velocity is just speed, but with a direction. So my speed on the way to work may be 55, well, let's not use miles per hour because we don't use that kind of stuff in physical science. Let's just say an object had a speed of 10 meters per second. But if I said the object had a speed of 10 meters per second north, that turns into a velocity once you add a direction. So a change in velocity can result in a change in speed, so did you go faster or slower? A change in direction, so if you turn or make a change in direction, that changes velocity, or both. So even if your speed doesn't change, if you're turning, your velocity will change. So like this car, let's say they're going 25 miles per hour around this curve. As long as they maintain 25 miles per hour, their speed will not change. However, because they're curving, they're changing direction, so their velocity will change. And that's a common mistake, is that if direction changes, velocity changes, but speed can still stay the same. So how do we combine them? Well, if you watched the section 11.1 lesson video, you saw how we add vectors. If they're in the same direction, then we add the magnitudes. If they're in opposite directions, we subtract the magnitudes. So two or more velocities add by vector addition. So here, we have the plane's velocity of 100 kilometers per hour and the wind in the same direction, 25 kilometers per hour. So we would add those to get a total of 125 kilometers per hour. Well, here we have the plane going in one direction at 100 kilometers per hour. The wind is going in the opposite direction of 25 kilometers per hour. So we would do 100 minus 25. So overall we would get 75 in the direction of the plane because the plane has the larger magnitude. So let's knock out this section assessment. So what does velocity describe? Well, remember, velocity is the speed and the direction of an object. So there's two parts, the speed and the direction of the object. What shows the speed on a distance time graph? It's the slope. What is the difference between average speed and instantaneous speed? Average speed is your speed over a range of time, whereas instantaneous speed is your speed at that moment or at that instant. That's where instantaneous comes from. Okay, so remember, at that moment, what is your speed? So think of a speedometer. How can two or more velocities be combined? Through vector addition, because remember, velocity is a vector, just like displacement. Does a car's speedometer show instantaneous speed, average speed, or velocity? Explain. Well, my car's speedometer shows instantaneous speed because it shows the speed I'm going right then at that instant. My speedometer does not show the direction, so velocity would not be an option for my speedometer. Now, if you had a speedometer that did also show you direction, then you could argue that your car is showing you velocity. But just based off of what my car is, it only shows me the speed at that instant, and there's no direction included in my car. So I would say instantaneous speed because it shows me that speed at that instant, and there is no direction. All right, so let's look at this math problem together. Again, if you want to, maybe pause the video and try it on your own, and then look back and check your answer. So a plane's average speed between two cities is 600 kilometers per hour. So this time they gave us the speed. If the trip takes 2.5 hours, so there's my time, how far did the plane fly? So if they ask how far, they're looking for distance. So that's the thing you have to be able to do. You can't just plug into a formula the way it is. You need to be able to rearrange a formula. So let's talk about that real quick. So our formula is speed equals distance over time. That means we're solving for speed. They want us to solve for distance. The thing you're solving for, the variable you're solving for, always needs to be by itself. So if I want to solve for distance, I need to get distance by itself. I need to get rid of the t. Move the t to the other side. So how do you do that? To move a variable from one side of the equation to the other, you do the opposite mathematically. So see how right here we're dividing by t? What's the opposite of dividing? Multiplying. So if I multiply both sides by t, because if you know anything about an equation, if you do something to one side, you have to do it to the other, then the t's on this side, see how one's on top and one's on bottom, they'll cancel and go away. And so then I get distance equals time times speed. All right, and so then I can plug in and solve for distance. So my time is 2.5 hours. My speed is 600 kilometers per hour. And so if you look, I have an hour on top and an hour on bottom. Remember, anything on top and on bottom, just like these t's over here, will cancel. So my hours cancel, and so I would do 2.5 times 600, and I get 1,500, and the unit that I'm left with is kilometers. All right, so hopefully if you tried that one on your own, you got it right. All right, and so that is section 11.2. So hopefully now you know the difference in speed and velocity and how to calculate them.